Hey, Intro to Algebra, here's a few quick notes on scientific notation, which you've probably seen before. I just want to make sure that you're taking notes. And on this first slide, there's some important stuff here. So remember that this number, this first number that we write, has to be between 1 and 10, but it can't be 10. It can be 1. And then we've got 10 to a power, and that power must be an integer. So it can be negative, could be 0, could be a positive number, but it's not going to be like 1/2 or anything like that. So if we want to write this number in scientific notation, the way we think about it is we think about, well, that's the same as 3.25 times 10,000. If we did 3.25 times 10,000, we would get this original number here. So 10,000, though, we know is 10 to the 4th, because if we do any power of 10, that really just tells us how many zeros there are. So 10 to the 4th equals 10,000. And similarly, if we had, like, for instance, 10 to the 5th, that's just a 1 with 5 zeros, just to remember. 1, 2, 3, 4, 5. But this is the one we need today. So we're going to write that as 3.25 times 10 to the 4th. And that's in scientific notation now. The 3 is between 1 and 10, and here is our power of 10. So you might think, like, why would we care? Why would we write it that way? And the reason is, if numbers get really, really big, like this number here, we don't want to have to write that all out, especially like if we're writing a book. So we write it this way. It also can help with the way that significant digits work, but one of the reasons is just helps writing out really big numbers. What about small numbers? Well, this 0.00325, that's the same as 3.25 times 0.01. Of course, now that 1, this is the 10ths place, this is the 100ths place, this is the 1000ths place. So that means that that's the same as 3.25 times 1 over 1,000. Well, let me write that as a power of 10. But remember, I want it to just I don't want a fraction here, I want 10 to a power. So I'm going to write that with a negative exponent. There we go. One shortcut that people often tell you is they say, well, it's how many times you move this decimal point. So 1, 2, 3 times. That's how I know it's going to be -3. Okay, we're going to do more practice, so we'll see that sort of shortcut business here in a second. So just to recap, when we have really big numbers, we have a positive value of 10. And when we have really small numbers like this, very much less than 1, we have a negative power of 10. So that's how you know, is this a really big number or a really small number? We're going to write these in scientific notation. 427,000, it helps me to write that out all in numbers. And then, of course, the shortcut that we talked about is we know the power of 10 by counting the number of times we would have to move the decimal point. So 1, 2, 3, 4, 5. If I'm going to make this into a number between 1 and 10, I'm going to write 4.27. And then I notice that it's those 1, 2, 3, 4, 5 places I had to move the decimal. So this is times 10 to the 5th. And the counting the decimal places is really just counting the power of 10. It's a positive exponent. And remember, that correlates with it being a big number. This one's going to be a negative exponent because it's a small number. But again, I'm going to count 1, 2, 3, 4. So this is going to be 2.077. It's not going to be times 10 to the 4th. It's going to be times 10 to the -4. 9 10,000ths. So I have to remember my place value here. Tenths, hundredths, thousandths. There's the 9 in the 10,000ths place. So I'm going to count my decimal places. This is also 9 times 10 to the -4. Or you could write it as 9.0 times 10 to the -4. Of course, that implies 2 different levels of significant digits, so it would matter in science, but for now we don't have an application. You also need to be going the other way. So this is a negative exponent, and that tells me that I'm going to make this number small, or smaller. I'm only going to move the decimal point 1 place, so this is just 0.1588. And this one, this is a big positive number, so this is going to get bigger. So I'm going to write 3.868, and then I'm going to count the number of times I move the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to put in 1, 2, 3, 4, 5, 6 zeros, and there's my final answer. Just a quick note about the way the Khan Academy works. What I found when I was trying this out is that rather than in X for times, you're going to use a dot. and that's this button right here. So as I typed this in, I typed 5.301, and then I hit the dot, and then I did 10 caret 7, and that came out just fine.